Have you ever wondered, how a massive sports bar or a giant retail store gets flawless 4K video to dozens of screens without just a total tangle of computers everywhere?
Yeah, it really is quite the logistical puzzle.
Right. So welcome to today's deep dive. We are looking at a product spec page from HDTVSupply for the DVIGear DVI-7313-RX 4K fiber optic receiver.
Quite a mouthful.
It is, yeah. But the goal here is to understand the totally invisible technology required to send ultra-high-definition video across massive, stadium-sized distances. Okay, let's unpack this.
Well, to really get it, you first have to look at the physical signal itself. I mean, if you try to wire up a sprawling commercial space with traditional copper cables, you run into physical limitations very quickly.
Because of the distance, right?
Exactly. Copper suffers from electrical resistance and electromagnetic interference as the cable gets longer.
I would think of it like trying to shout instructions across a really windy field. Like the wind acts as interference and basically scrambles the sound.
That is a great analogy. That's essentially what electromagnetic interference does to an electrical signal in those copper wires.
So if copper basically just turns into static over long distances, how do these massive stadiums actually get around it?
Well, they stop using electricity altogether. What's fascinating here is the literal mechanics of the transition. The transmitter module in this DVIGear system actually takes standard DVI or HDMI signals.
Which the specs say is version 1.4, right?
Yeah, version 1.4, which gives you 4K resolution at 30 frames per second. And it takes that signal and converts it into actual physical light pulses.
Oh, wow. So you're basically trading your voice, shouting across a field for like a perfectly aimed laser pointer in a vacuum.
Precisely. And since photons traveling through glass don't experience the friction or the outside interference that electricity does, the distance capabilities are just staggering.
How far are we talking?
Well, the DVI-7313 shoots those pulses down a single strand of multimode fiber optic cable for up to 1,640 feet.
Multimode meaning the light is sort of bouncing around a bit inside the core of the cable as it travels.
Yes, exactly. Which does eventually limit the maximum range. But the source also mentions its sibling, the DVI-7314, which pushes that signal up to a staggering 1.2 miles.
Wait, 1.2 miles? That is insane.
Right. It does that using single-mode fiber. Single-mode uses a laser-focused, straight down a microscopic core, so it stops the light from bouncing at all.
Ah, so that is how it achieves that massive distance.
Yeah, and then on the other side of the building, the receiver translates those pulses instantly back into high-resolution video.
Okay, I have to push back a little here, though. Over a mile of distance for a single video feed just seems excessive. Like, why go through all the trouble of converting video to light? Why not just stick a tiny media player behind every single TV on the wall and call it a day?
Well, for systems designers and integrators, it really comes down to usability and maintenance. If you have 50 media players scattered across a giant facility, you literally have 50 separate points of failure.
Oh, I see. Requiring someone to drag out a ladder every single time a video buffer gets stuck.
Exactly. A total nightmare for any retail worker. In fact, there is a customer review on the spec page from a buyer named Victoria in LA that highlights this perfectly.
What was her situation?
Well, her retail staff needed a matrix system, which is essentially a central hub allowing you to route any input to any output seamlessly, and they needed it across multiple store locations.
Got it.
So centralizing the tech into one hub, distributing light pulses, makes that plug-and-play usability actually possible for staff who aren't tech experts.
Because they are just controlling the hub, not 50 individual monitors. But wait, don't different TVs require completely different settings?
Yeah.
I feel like plugging 50 random screens into one hub would just cause a massive resolution nightmare.
That is a totally fair point, but the DVIGear transmitter handles that with an internal EDID memory.
EDID?
Yeah, it stands for Extended Display Identification Data. Think of it as a digital handshake, where a TV tells the system exactly what resolution and frame rate it can handle.
Oh, that is smart.
Yeah, the transmitter automatically acquires and remembers the specific specs of every connected display.
So the retail staff doesn't even have to troubleshoot mismatched refresh rates. The system just remembers what each screen needs and fires off the correct light pulses automatically.
Right. It handles all the heavy lifting completely invisibly. You bypass the limitations of electrical wiring entirely.
Gaining extreme speed, massive distance, and that centralized control.
Exactly.
So what does this all mean? It means that building the seamless, flawless tech experiences we expect in massive commercial spaces requires literally converting our digital lives into actual beams of light, which leaves you with a really interesting question to ponder.
Oh, what is that?
If commercial spaces are completely reliant on transmitting data via light pulses to overcome the limitations of distance and speed, how long will it be before the traditional copper cables hidden inside your own home's walls become completely obsolete?